And welcome again. In this video, we are going to learn how to find the acceleration of a point on a rigid body in plane motion. And we got a picture here. This is basically an example of plane motion. The last thing students study in +2 syllabus in mechanics, in the name of mechanics of rigid body. And we got a problem. We have hinged structure, and one end of the hinge structure of two identical links of length 2a. There are two links, both of length 2a, and one of the ends is fixed. I can see that fixed end. This end is, I guess, fixed. Its other end moves at a constant speed. Constant speed. To having a constant speed is always not only constant speed, but its direction is also constant, because the other end moves at a constant speed v in a straight line. And we are fortunate enough, anytime we wish, we can place an observer here, and this will be the observer of inertial frame. So we are fortunate enough to have this in this problem. The distance to which from the fixed end of the structure is equal to 2a. There is the distance 2a and this whole length is 4a. So both are not going to be straight anytime. Find the acceleration of the hinge at the moment in time when the left link is horizontal and the joint speed is 0. So there is an example of fixed axis rotation. The left link is in fixed axis rotation with axis of rotation passing through this point, and the right link is an example of translation and rotation. And basically it can scare us, the complexity of the problem. But we are going to analyze the problem first. We need to find the loose ends of the problems and analyze them properly as by the book. And I can say here, since the left end of the structure link is fixed, hence the hinge will move along a circle of radius 2a at any moment of time, and its velocity vector will be perpendicular to the left link. Okay. And what happens when the left link is horizontal? I'm going to draw this picture again, because when making left link horizontal, because I'm not seeing anything at all in this problem worth solving. So left link is horizontal, right? And where is the right link? I don't know. I'm going to draw something like this, and this is going to make no difference. And there is one more thing to draw, the right hand side of the guide, along which this thing is moving. Okay. That looks nice. And the velocity of this end is v, and that is constant. So I know that this length is going to be a anyway, because the whole length is 3a. I know the whole distance between these two guides is 3a. But I am more concerned about the left link is horizontal at this moment, and this end has a velocity v, right? And since this is a rigid body, this rod, this link is a rigid body, so if I suppose this angle is alpha, then the velocity of this end is also going to be v cos alpha, because this end has got the velocity v cos alpha. That means but the hinge velocity should be perpendicular to this. That means velocity of this hinge is v. Velocity of this hinge is v. That's right. I got something to move on. The velocity of this point will always be perpendicular to this line, because this point is fixed. So left end of the, what was its name, link, left end of this left link was fixed. So the extreme left point in this figure is fixed, so it will always move in a circle with a radius 2a. So its velocity must be perpendicular to this left link, which is horizontal, so its velocity must be vertical, and I got a sense that it must be in vertically downward direction. Its velocity is increasing, decreasing. What happens? I can guess that since it is moving on a circle, so I can guess, I'm just analyzing things. It is moving in a circle to a circle. That means this alpha is going to increase. Alpha is not constant, alpha is an instantaneous angle. So this alpha is going to increase, and that means v cos alpha is going to decrease, because alpha increases then cos alpha decreases. That means its speed is going to be decreasing. So acceleration, इसका acceleration, उस point का acceleration जो होगा इस hinge का. So I'm going to remove few things. I already thought much. So I can think कि इस hinge, the acceleration of the hinge, and it's going to be in this direction as well. In this direction as well. And since it is moving in a circle, so it will have both the radial acceleration and the tangential acceleration both. And that is making me nervous. This is making me nervous. So I'm going to use my second weapon. And what is that? That is, I'm going to put an observer here. This is the observer of inertial frame. And with respect to this observer, this is an observer of inertial frame, because its velocity is constant. Magnitude, direction, both are constant, and this hinge thing is at rest with respect to our observer. So it may have a velocity. This is right now, this is at rest with respect to our observer. So what will be the change in velocity? And this length is not going to be constant. This length, this is a rigid body. This length is not going to be constant. And its velocity, it is not moving basically. Its velocity is 0 at this moment with respect to our observer. Our observer is moving with velocity v, and with respect to its velocity is 0, and its length is going to remain constant. So in the next moment, its velocity will be perpendicular to this line. Perpendicular to this line. But in which direction? Its speed is going to decrease. So हमारे ऑब्जर्वर के रिस्पेक्ट में, with respect to the observer of our inertial frame, its acceleration will be in this direction, because next moment it is going to get some velocity in this direction, because in this direction it cannot get any velocity. And that means the velocity of the hinge at the moment with respect to our observer is 0, and it's going to get its velocity in a direction perpendicular to the right hinge. So the acceleration will be automatically in that direction, because it is at rest at this moment. So in the next moment it is going to move perpendicular to it. Which perpendicular? This direction or this direction? I don't know exactly, but I guess its velocity is in this direction, because I earlier thought from this point of view that acceleration of the hinge will be in this direction from this point of view and in this direction. So resultant of both these acceleration is going to be this. So I guessed with respect to our observer, its acceleration is in this direction, and it will be same with respect to observer at rest with respect to any inertial frame. That means with respect to this point or with respect to this moving observer, the acceleration is the same, and acceleration of the hinge in the first case is this. That means when the left link is horizontal. So I guessed all those things. The acceleration is in this direction. So my analysis is complete now. I'm going to find out the acceleration, the magnitude of acceleration. If this angle is alpha, this is vertical between vertical and this angle alpha is between vertical and this. So horizontal and perpendicular to this line, this angle is also alpha. And I knew that with respect to ground, the velocity of this point is v, and acceleration is this, and acceleration has two components, in this direction and in this direction with respect to this hinge. This not hinge, this is fixed point. It is also a hinge. There will be a range at that point as well. So, and this is the length 2a. So its radial acceleration of this point should be v square by 2a, and this radial acceleration is the component of net acceleration of the hinge, and that is a cos alpha. That means v square by 2a is equal to a cos alpha. That means the value of a is equal to v square by value. A is the length, and so look, I need to write down the acceleration in terms of w, not a. A is something else here. So this is wr, and this is what equal to cos alpha. मैंने ये क्या लिख रखा था Forget it. Oh, I should have wrote that omega cos alpha equal to W cos alpha equal to WR. W is for acceleration, because A is reserved for something else, so W is the acceleration here. That means B square by 2L equal to W cos theta. So W, the acceleration of the hinge at this moment, is V square by 2A. This was also not cos theta, this was cos alpha. So by 2A cos alpha, and who is going to get cos alpha for me? This length is A and this length is 2A. So cos alpha is equal to under root 2A whole square minus A square by 2A. This is root 3 by 2 cos alpha. Alpha is equal to pi by 6, and get your result. Finally, by putting all those things, you can get your result. And what can we do about the next case? That is when the joint speed is 0. B is decreasing right at this moment. So joint speed is 0. When will the joint speed 0? That is the main question. When will the joint speed 0? Oh, I can get it. I can get it quite easily. When the joint speed is 0, I can get things. Can I rotate the whole picture? Is it possible? No, I can't do it. So I'm finally going to remove it. And I'm drawing again a new picture. This is the fixed end, and this is the guide along which the other body is moving with a constant velocity. And if I draw something like this, and I can guess here, its velocity is obviously, I don't need to guess, its velocity is B, and since it's a rigid body, so the component of velocity, the velocity of this point is V, so the component of velocity in this direction is 0. And what was the problem exactly? The joint speed is 0, and now the joint speed, this speed is also 0, because this speed is 0 and this speed is 0. So in this direction, so its speed is 0 in this direction. And what about this direction? This direction, joint speed should be 0, because the velocity components of this right link along the along the body itself should be equal. If this velocity is 0, then this velocity is also 0. So nothing else. This velocity is 0 here, and if I tell this angle is alpha, so this angle is again alpha pi by 6, because this length is again A and this length is 2A, and everything reverse. If I reverse everything, this is the same problem. If I think instead of everything else, if I think that this is the fixed end, and this end has got velocity v, and it means with respect to its velocity it is at rest. The hinge it is at rest with respect to this moving thing, and the problem is same. The joint speed is 0 thing is the same problem. Just if we reverse the whole situation, this is the same problem as before. Think about it. I'm not going to solve it because there is nothing to solve about it. Thank you very much for watching.